Hello and thank you for watching my video. My name is Astrid Krasniqi. I'm CCNA and CCNP certified instructor. On this video, we are covering new topics added to the CCNA course 200-125, and this is section 4.6 LAN Security. Upon completion of this section, you should be able to explain how to mitigate common LAN security attacks. First, LAN security best practices. AAA with Radius and TACACS+. Now, basic access control on the network device is enabled using authentication. There are different methods to implement authentication on a Cisco device, and each method offers varying levels of security. When you configure line console 0, for example, and say password Cisco login. Now, this login command says, okay, well, you have to use this password to log in. For example, if you configure a remote line, so line VTY024, password Cisco as well, login. Now again, this login command here says you should be using this password for logins. But if you say login local, now you have to create a local database, because you are saying, okay, well, you look at the local database. To create the local database is username, for example, student, and the password Cisco. Now this command, this password here, doesn't have any meaning whatsoever. It can be even deleted. When you say login local, you are saying use a local database. So the following describe the two common methods. Simple password authentication. This involves using the password and login lines configured commands to protect the console, VTY lines, and AUX port. This is the weakest and least secure method. It provides no accountability. So if we open, like for example, like it was before, just password without this, right? I'll cut that. Just like this, password Cisco and login. Now anyone with this password will be able to log in. We don't have any accountability who logged in, when, or what did they do, and so on, right? So if we say, for example, get rid of this and say login local, and put the local database, for example, what was it, username student and password Cisco. Now, okay, when somebody logs in, we know that user student has logged in at a certain time. So that does provide a little bit of accountability. So local database, that is a local database authentication. This involves creating local user accounts with a username and secret password, global configuration command, and then configuring local line configuration command on the console, VTY, and UX port. It provides additional security because an attacker is required to know the username and the password, and as well as it provides accountability. So simple password authentication, if I just go back to here, simple password authentication was line VTY024, password Cisco, and login. That's our simple. That is no accountability whatsoever. Here, if you put the login local, we are using the local database, and this is global configuration command. So, and it has some kind of accountability. Either way, is not scalable at all, because you have to go to each device and create a username and password. So the best method would be to use Radius or TACACS. These are their external servers. So we use AAA or Quad A authentication. Now AAA stands for authentication, one of the A's. The second A stands for authorization, and third one for accounting. Authentication is the process of identifying a user before that user is allowed to access the protected resource. So first we authenticate our users, then we authorize them what users can do on our devices. After the user gains access to the network, authorization is performed. Authorization allows you to control the level of access users have. And then we have accounting. Accounting is performed after authentication. Accounting enables you to collect information about the user activity and resource consumptions. So AAA with Radius and TACACS, like we said, local database method does not scale well. Most scalable solution is to use a database on central server. Cisco devices do support this AAA framework to help secure device access. Two AAA authentication protocols are supported on Cisco devices. We have terminal access, controlled access, Control System Plus, or you don't want to now say it so many times, just say TACACS Plus. Now TACACS Plus is a Cisco proprietary protocol, and we have another open standard protocol, which is Remote Authentication Dial-In User Service, or Radius for short. Now, difference between the TACACS and Radius Plus, there are three critical factors for TACACS Plus. Separates authentication and authorization, encrypts all communication, and does utilize TCP port 49. In the Radius, combines the Radius authentication and authorization as one process. And Radius, which again, remember, is open standard, encrypts only the password. Radius utilizes UDP, so it's an unreliable protocol. The port number is 1812 and 1813. Radius does support remote access technologies such as 802.1x and Session Initiation Protocol, SIP. TACACS Plus is considered to be more secure protocol because it's encrypting all communication. So TACACS is encrypting all communication, while Radius is encrypting only the password. TACACS Plus protocol exchanges are encrypted, while Radius only encrypts the user password. So 1812 and 1813 UDP, and 49 for TCP for TACACS. Here we go. So developer for Radius, Livingston Enterprise, now it is industry standard. TACACS Plus is Cisco, proprietary. Transport protocol for Radius is UDP port 1812 and 1813, while TACACS is port 49. AAA support combines authentication and authorization and separates accounting. TACACS Plus uses the AAA model and separates all three services. Radius challenge response, only one way unidirectional single challenge response, while TACACS has two-way bidirectional multiple challenge responses. So with the Radius, for example, you are just challenging, or the server is challenging the client, while with TACACS the clients challenge the server, as well as the server will challenge the client. And like we said, for security, we'll encrypt the Radius only the password, while TACACS is encrypting the entire packet. IEEE 802.1x standard defines a port-based access control, an authentication protocol that restricts unauthorized workstation from connecting to LAN through the policy accessible switch ports. The authentication server authenticates each workstation that is connected to the switch port before making available any services offered by the switch or the LAN. So, for example, if you don't have 802.1x, as soon as this client computer connects to the network, it starts to communicate, broadcast, multicast, unicast, it starts sending frames. Now, then after the user logs in, then the user can be authenticated. But with this protocol 802.1x, the workstation is not allowed to go to the LAN or communicate to LAN at all. It only allows authentication frames to go through. So this computer, without being authorized, is not able to communicate at all on the network, even if somebody is on or logged in or not. So 802.1x components that we have is client, Supplicant. This is usually the 802.1x enabled port on the device that requests access to LAN and switch services, and then responds to requests from the switch. Then we have a switch authenticator, control physical access to the network based on the authentication status of the client. The switch will act as an intermediary proxy between the client and the authenticator or authentication service. So we have a client, that's our PC, then we have a switch, then we have an authentication server. Performs the actual authentication of the client. The authentication server validates the identity of the client and then notifies the switch whether the client is authorized to access the LAN and the switch services. Now sometimes this authenticator, I like the word authenticator because sometimes they call it authentication client as well. On some books you will find it as authentication client, authentication server, and just client. It confuses things out. This is a better word for it. Next thing is DHCP snooping. DHCP spoofing. Attacks occurs when a rogue DHCP server is connected to the network and provides a false IP configuration parameters to legitimate clients. Use DHCP snooping to mitigate DHCP spoofing attacks. DHCP snooping recognizes two types of ports. Trusted ports. These are the ports that they should offer an IP address or acknowledge. So they come in the ports that they come in from the DHCP, a trusted DHCP server, are considered as a trusted port. And we have an untrusted port. These are connected to pretty much every other port. So these ports connect to hosts that should not be providing DHCP server messages. By default, all switch ports are untrusted. So when you enable DHCP snooping, the ports, all of them are untrusted. So you have to make a trusted port, the port that's connected to the DHCP server. And other ports are untrusted. So this port, for example, is going to be able to send DHCP or IP offers and DHCP acknowledge messages. So DHCP offers and DHCP acknowledge. So they can come here, this port, it's got to be trusted. And go down here, trusted. If this user tries to attack, or attackers tries to send the DHCP messages, this port will be blocked. We'll see it in our lab if I can configure it very quickly. For each untrusted port, DHCP Snooping builds and maintains a database called the DHCP Snooping binding database that includes the client's MAC address, IP address, and other information. The switch will deny packets coming from untrusted port that contain any of the following: unauthorized DHCP server messages. Remember DORA process. The server messages was the second, the DHCP offer, and the fourth, DHCP acknowledgement. Unauthorized DHCP client messages not adherent to DHCP Snooping binding database or rate limits. DHCP relay agent packets that include option 82, information coming from untrusted port. To configure DHCP snooping, first you need to enable snooping in the global configuration mode with the command IP DHCP snooping, or you can enable it per VLAN, so IP DHCP snooping, VLAN 10 or VLAN 20 or whatever you have. And then you need to disable the IP DHCP snooping information option. Now this information option, it can cause some problems to some DHCP servers, as they're not expecting some of the information they will be added on the DHCP discovery message, like the port ID and so on. So we need to disable this. Then we need to, for example, limit to how many DHCP messages they come in from the PC. By default, there's no limit, and we can limit a range from 1 to 2048. This is how many packets per second are coming from the clients. When we enable the DHCP snooping, one of the interfaces has to be as a trusted, and the trusted interface is going to allow the DHCP offers and DHCP acknowledgements. So for example, the DHCP offers will be allowed to come in this port, DHCP acknowledgement will be allowed in this port. So DHCP messages like offers and acknowledgements are not going to allow on any ports except DHCP discovery and DHCP request. Remember the DHCP, the DORA, discover comes from the client, offer comes from the server, request from the client, and acknowledgement again from the server. And then to see it, we can view, for example, with the show IP DHCP snooping database or detail. Now I've got this lab here that we're going to configure. So I've got a connection to one of the routers. So it did show session. This is my router 1. There's no configuration there whatsoever. And I've got connection to the DLS one as well as two virtual PCs with a physical network card. These are my PCA, for example. The PCA, if you want to check if it's DHCP enabled, you do ipconfig all, and that will show you that, okay, well, this is not a DHCP enabled and it's got an IP address configured. So we want to be the DHCP client for this machine, so we have to go to properties of that interface and select obtain an IP address automatically, as well as the DNS. Click OK. I do for the second PC, PCC as well. So right click, properties, IPv4 automatically, and the DNS. Okay, so if I go to PCA now, because I have not configured the DHCP, so if I do ipconfig, you can see the IP address is assigned a PIPA address. So if I go to PCC as well, I do ipconfig, you can see there's no address there, it's a PIPA address. Okay, so if I want to access router 1, I press 1 and press enter. Then if I want to, I just type no here. You can see there's no configuration, no startup configuration. If I want to go back and then go to DLS2, I'll press Control Shift 6 and then X. That will take me to my access server, and then press number 2 to go to DLS. Now you can see the DLS doesn't have any configuration either, so I'll type no and press enter. I go back to my router 1, and the configuration that I've got here is a startup configuration, so I can go slowly one by line, but you should really know this startup configuration. If you don't, see my video on CCNA 1. So I highlight that, I right click, click copy, then go to router and press right click paste to paste it there. I go back to my notepad and just highlight this. If I look, this is my configuration, so router 1 interface G00, that description towards the LAN, and that's the IP address, no shutdown. That's it. Right click, copy and paste it on my router, no shutdown. Okay, so to verify it, show IP interface brief. That IP address interface just come up. Excellent. Okay, so first what we're gonna do is we're gonna enable DHCP on router 1. So router 1, now by default the service DHCP is running, so you can disable by saying no service DHCP if you don't need DHCP, or you can enable by just saying service DHCP. We need to exclude the addresses that we don't want to issue to the client, so excluded addresses. For example, the exclude address from 1 we're going to exclude to 10.1.1.9, so the first 9 addresses are not going to be issued. Then we create a pool, IP DHCP pool. We're going to call this R1 LAN, and in here we type the network, so 10.1.1.0, that's our network, and the mask /24. Default router it's 10.1.1.1. Domain name, let's say CCNA.local, and DNS server, say 10.1.1.5. We don't have a DNS server, but just pretend. So highlight all this information, right click, copy, go to my router and paste it there. So config T first and then paste it. Excellent. So if I go to my PC, so PCA, and just see if it's getting an IP address. So if ipconfig, not yet, ipconfig renew, let's see if we are getting an IP address. Yep, we got an IP address, that's our domain name, as you can see, an IP address .10, and cool, the default gateway is there. Let's just see to see the DNS, so ipconfig all, and our DNS is, as we said, .5. Cool, so let's do for PCC. Let's just see, maybe it's got already an IP address. Nope. ipconfig renew. Okay, now we got the IP address 10.1.1.11 for PCB. Okay, so if I go to now I need to enable the DHCP snooping. So if I type, for example, go to now I need to go to DLS. So let me just copy the startup configuration for the DLS. So hostname, it's going to be DLS1, and then I'll just copy the startup config first and paste it there. Cool. Now I'm going to go to do my notepad, and this configuration is going to be for my DLS, and I enabled my DHCP snooping. So DLS1, the config is going to be first of all enable the IP DHCP snooping, so IP DHCP snooping, and then we can enable like this global the global configuration mode, or we can enable per VLAN, so IP DHCP snooping, a VLAN, for example, a VLAN 1, 10, and so on. We can enable per range. Then we need to disable, so no IP DHCP snooping, disable the information option. Then we need to go into one of the interfaces, and we have to make it as a trusted interface. So for example, select the FA03 is going to be our trusted interface. So interface FA03 and IP DHCP Snooping, Trust, and then we can go to the interfaces like where the hosts are connected, and we can make them like we can limit how many DHCP requests or broadcast messages that can come. So interface range, we can do it here, FA11 to 12, for example, and say IP DHCP Snooping, limit rate to say 25. Okay. So we enabled the DHCP Snooping in there. We enabled the per VLAN. We disabled the information option, and we made the trusted interface. Okay, everything seems to be fine. So copy, go to the DLS and paste them there. Okay, end. So if I go to the client machine and just release my IP address, so IP config, release, and renew, IP config, renew, and see if DHCP Snooping is working. Okay, so I got the IP address, so I'll go to the PCC, do the same thing, IP config, release, and IP config, renew, and then I'll go to my DLS and check the DHCP Snooping. Show IP DHCP Snooping, and the options here is binding, database, and statistics. So binding, for example, so we have, you can see that this IP this is already snooped. This MAC address has got this IP address, and this is the lease, and type is DHCP Snooping, VLAN 1, and the port as well. So a lot of information here. For example, IP DHCP statistics, we can see the packets that have been forwarded, how many packets have been forwarded, drops on untrusted port as well. Thank you very much for watching. Please have a look at my other videos and don't forget to subscribe. This has been Astrid Krasniqi.